Hi guys, welcome to Science in 5. In this video, we're going to look at some revision questions for grade 10 wave section. Now the grade 10 wave section contains some important calculations, and one of those basic calculations is to do with the wave speed formula. There are two versions of this formula that you need to quickly get used to and know how to apply. The first one says speed of a wave, or speed in general, is distance over time. Okay. And the other one says speed is the product of the wavelength and the frequency of a wave. Okay. Now, the important trick is to know when to use these formulas. Now remember, at this point in time, once you get a formula, you can be asked to calculate any one of the quantities in the formula. So if a question asks you for the time, which of these two formulas has got time? That one. So you most likely you're going to lean towards this formula. Okay, so if you want to calculate the time it takes for a wave to bounce off of something, that formula. If the question says distance, calculate the distance between the dolphin and the rock, or the ship and the seabed, you're going to lean towards that formula. Now then, another question will ask you to calculate the frequency of a wave. So now you're being asked to calculate the frequency of a wave. Well, you're probably going to need to lean towards this formula. If the question says calculate the wavelength of this wave, which means you're going to have to lean towards the formula that has got wavelength. Okay, so it's a very important technique. All you have to do is list the given information that you're given from the question, and then once you do that, you will be able to calculate whatever quantity that you want to calculate. Okay, now the first wave speed that says speed of a wave is equal to distance over time is fairly straightforward. But where does this formula come from? Well, if I was to draw one wave like that, and then I say, well, the length of this wave is lambda. In other words, the wavelength from one point in phase, from the distance between 2 points rather that are in phase, or two successive points that are in phase. All right. And then this wave takes a time t equals big T. Well, we know what the big T represents. The period of a wave. What is the time it takes for one complete wave cycle? We use the symbol big T. All right. But we also remember that the period and the frequency are related with this formula. And remember, the frequency of a wave is simply the number of complete waves emitted per second by a source. Okay, so let's say I wanted to get the speed of this wave. I will just basically say speed equals distance over time. What is the distance traveled by this wave? Is lambda. What is the time taken for one wave to travel? Is the period. But I also remember that, well, the period of a wave is linked by this formula. The period equals 1 over f. So, where there is big T, I might as well rewrite this equation and say lambda divided by 1 over f. In dividing fractions, we've learned that in maths, you can change division sign to multiplication and invert. So I'll remain with lambda times f over 1. This becomes lambda f. Therefore, now I can say V equals lambda f. So that is where this equation comes from. Okay, just give you a background. So one part of the calculation is to do with this wave speed formula, how to use it. V equals d over t, or V equals lambda f. if you're still struggling with these formulas, perhaps the first thing you could do is just to draw a triangle for these two formulas. Like that. Okay. Let's start with the distance time one. You see, the speed equals distance over time. You can also calculate the time from this. You could say the time equals distance over speed. Okay? You could say the time is equal to distance over speed. Or if you wanted to work out the distance, you would say the distance equals speed times time. Then here you can also have speed equals the product of the wavelength and frequency. So the speed is the product of the wavelength and the frequency. And again, from this triangle, we can get two versions of this formula. We can just say the wavelength is the speed over the frequency, or we can actually get the frequency equals the speed over the wavelength. Okay, now let's just take a look at some basic questions involving waves and how we can just use this wave formula to solve some problems. Remember, the trick is to pick out the relevant information from the question and then run with that. Just try to list the information given and then see how it goes. So, we got a question there. Question 2. Well, we're told in question 2, a dolphin is swimming in deep water and it emits ultrasound of 30,000 hertz. So 30,000 hertz means we have been given the frequency, guys. The unit for frequency is hertz. The ultrasound traveled a distance of x meters, we don't know what the distance is, and are detected 4.6 seconds later. So we are being told something about the time. Okay. This is known as echolocation. The speed in the water, v. Okay. Calculate the wavelength emitted by the dolphin. We said we've got two formulas, distance over time, product of wavelength and frequency. We are being asked for the frequency. Which of these two formulas are we going to choose? The one that has got frequency is obviously that formula. So which means we need the other two quantities. In fact, we want the wavelength, so we need the other two quantities. The speed is given as 1.5. The frequency is given as 30,000. So which means we can now work out the wavelength. So we said, well, wavelength is going to be equal to speed over frequency. Remember the triangle? We said speed, wavelength, and frequency. Wavelength is speed over frequency. So the wavelength is the speed over the frequency, which is 1,500 all over 30,000. This gives me 5 times 10 to the minus 3. Wavelength is measured in meters. So I've got my wavelength there. Simple as that. So all I did was to look at the information given. I want to calculate the frequency. Which of the two wave speed formulas should I pick? The one that has got frequency. So that's the trick with these calculations in waves. List the given quantities. Try to look for which quantity that you need. Is there a formula that links them up? If you can do that, question becomes easy. Question 2.2 says, calculate the distance x that the rock is from the dolphin. Which of these two formulas has got distance? It is that one. Speed equals distance over time. Again, if I make a triangle, I said speed, distance on top, and time, which means to get the distance, I need the speed and the time. I already know that the speed is 1/500. Now the trick here, guys, is about the time, because we have what is called echolocation. So basically, if I have a source, and this is like a barrier where the sound is going to bounce off, right? So what will happen is the waves are going to travel to the barrier, and they're going to bounce back, and they're going to go back to the source. So let's read the question. They say 4,6 seconds later. They're detected 4,6 seconds later. So it means from the time they leave, the waves go there, and then they come back. That's a total of 4,6 seconds. Which means, guys, the waves are going to take 2,3 seconds one way and 2,3 seconds the other way. That's how we get the total of 4,6 seconds. So from the time they are emitted to the time they are detected, there's that 4,6 seconds. So 2,3 seconds to travel from the source to the barrier. Now we want the distance d, that is between the source and the barrier. So what we're going to do is we're going to use the 2,3 seconds and the speed and to get the time. So now we've got the time. It's now 2,3 seconds, and we want the distance. If we go to this triangle, we'll discover that the distance is speed times time, which is 1,500 times the 2,3. So 1,500 times the 2,3, 3,450 meters away. Okay, so this calculation 2.2 is a bit tricky because of the time. I know the time value sometimes confuses learners. They're like, oh, why are we dividing by 2? Remember, the sound waves travel and then they are reflected. So the total time of travel is the time from they are emitted to go to the barrier, and then they reflect and bounce back and they're detected. So we have to divide by 2. Okay. Now let's look at this question that says, state 2 other uses of ultrasound other than echolocation by animals. Well, we can have medical imaging, producing medical images. For example, ultrasound scan of pregnant women to see the developing fetus. We can also use ultrasound to evaluate the blood flow. Diagnose disease. Ultrasound is also used there. Here, there's a technique, or the science behind it is known as the Doppler effect. Okay, very interesting to read that and find out what the Doppler effect is. We'll talk about it probably later on in grade 12. Okay, for those who don't do IEB. For those who do IEB, well, probably not. It's not in your syllabus. Then we also have what is known as sound navigation and ranging. You can generally call a sonar, not the State of the Nation address, but just a sonar as well. Okay. So I hope this sort of like gives you an idea of how to use the two wave speed formulas. The speed of a wave is equal to distance over time. The speed of a wave is the product of the wavelength and the frequency. Hope this clears up something, guys, and you can answer these questions much better. Probably in the next video, we're going to look at graphical representation of waves, talk about longitudinal waves, and also involve these calculations and see how to determine the speed of the wave given a graph and things like that. Ciao, guys. I'll catch you next time. Keep the science alive.